All right, in the last video, I took you through the math behind optimal bundles. And again, remember the idea behind optimal bundles is that consumers are trying to maximize their utility, but they're constrained in their ability to do so. And so basically, the way that we think about it is that the indifference curves, which represent levels of utility, sort of in a sense represent what's possible. What can I get to in terms of, my consumption, right? And as if I'm able to consume more and more and more, I'm going to be happier, right? We can see that generally more goods means happier goods, but I am then constrained in my ability to consume. And then this, of course, ultimately defines my behavior towards whatever it is that I'm actually consuming. And so then we found out, or I illustrated to you, that optimal bundles can be found at the tangency between the slope of the budget constraint and marginal rate of substitution, with the marginal rate of substitution just being the slope of the indifference curve. So we do some relatively, a little bit of calculus, a little bit of algebra, and this allows us to get at those optimal bundles. Now, going back here to the general solution to the optimal bundle, one of the things that I sort of mentioned at the very tail end of the last video was that we can think about X and Y in terms of demand, right? So it's utility maximization is the process that we believe creates demand in the economic system. And so whether we're talking about aggregate demand or whether we're talking about demand for particular products, the idea is that demand comes from utility maximization. And so the extent to which particular goods or to the extent that goods in general are being demanded in your economic system is going to be a function of preferences. So what do people like and what do they not like? What do they have to pay in terms of prices? And how much money do they have, right? And so from a macroeconomic perspective, we can't do a whole lot necessarily about, preferences, but we can certainly, for example, have stability in terms of inflation. So prices remain consistent and stable. And we can try to ensure that people's incomes are growing and also consistent. And so again, you can start to see, even though we're sort of talking about the microeconomics of it, we can sort of see there's some policy ideas starting to sort of form here. Right, the low stable inflation, right? The consistent economic growth, right? These things are here, even though we're sort of talking about individual decisions. Those policies potentially are going to show up there. Okay, so before we get into the actual intertemporal budget constraint, and again, thinking about consumption now over a lifetime as opposed to just thinking about consumption with respect to a couple of goods. What's really important in this part of these ideas is income and substitution effects. As we saw previously, when prices changed and nothing else changed, the optimal bundle still changed, right? Because the consumer was now facing different prices. And when prices change, this potentially causes consumers to, so for example, let's say the price of a good rose, this may mean that the consumer has to pay higher prices and therefore they might consume less of other goods. Or it certainly could also be the case that if the price of a particular good rose, that I might substitute away from it. All right, so there's a substitution effect with price changes. In addition to a substitution effect, there's also an income effect, because if prices go up, now assuming that I still want to consume both goods, now I have less income that I can use to consume the other good, assuming that I still want to consume positive units of the good whose price has just increased. And so one of the more interesting parts of utility maximization is these income and substitution effects. So when the price of a good changes, to what extent does it trigger substitution, and to what extent does it trigger income effects? And this is important because Again, when we start talking about intertemporal utility here in just a moment, when things like interest rate changes occur, there are likely going to be both substitution and income effects that ultimately define how people optimally respond to, again, those interest rate changes. And so graphically, the way that we can think about substitution and income effect changes is so, for example, here we can see that what has occurred is that, let's see here, the price of good one has decreased. Okay, so the price of good one was originally gave us this budget constraint right here. And with this budget constraint and this indifference curve, I had an optimal bundle at bundle A. Okay, then X1 became, I'm sorry, good one became cheaper. This caused my budget constraint to shift out in this direction. Now I'm able to consume on a higher indifference curve. Now there's going to be a positive income effect because now I'm spending less on good X. Also, because good one is now less expensive than it used to be, I might also substitute away from good two. So because good one has gotten cheaper, I may turn around and consume less of good two than I was previously. Or it could be the case that because the price of good one has fallen, I may increase my consumption of good two because now I have more money to do so. Ultimately, what governs the substitution and income effects here is going to be preferences, right? So we can see in this particular example, the individual moved from bundle A to bundle B, and we can see that bundle has more of both goods. Bundle B has more of good one, and it has more of good two. So the idea is that movement from A to B, part of that movement was an income effect, the income effect from the price of good one being cheaper. And then also some of this movement was going to be a substitution effect, which is that because now good one is cheaper, I'm going to consume more of it compared to good two in terms of ratio than I was before. And so this is sort of complex, a complex idea, but it's really important ultimately in terms of how we think about utility maximization. So to what extent do changes in prices lead to income and or substitution effects? And ultimately what's going to govern this is going to be individual preferences. So I have some examples here in the slides that I want you to take a look at that just sort of walks you through, okay, so here's the initial setup. Here's that utility function we had before. Here's an initial budget constraint. When you do the math, you get optimal bundle of X to be 25 and optimal bundle of Y to be 50. Okay, so 50 units of Y, 25 units of X, right, initially. Then the price of good one fell to one. So it was, I'm sorry, price of good X fell to one. It was two. Now it's one. Now, when you recompute it, you can see that the consumption of X rises from 25 now to 50. And so we see that I now consume more X because of the lower price. But let's think about this in terms of substitution and income effects. So in order to do this, we're going to look at the utility level originally. What was my original utility level? So I was originally consuming 25 units of X and 50 units of Y. And so therefore, my utility was around 35, a little bit more than 35. Now, at the new prices and at the new optimal bundle, which again was 50 and 50, I see that in order to maintain the original utility of 1250, I would need to change my consumption of X and Y to be both be 35. So basically, what ends up happening here is that the hypothetical is, imagine for a moment that we, in this case, because the price of good one has fallen, it's essentially how much money could we take away from you such that you are just as happy as you were before? How would you react to that particular scenario? And that creates what we call here a compensated bundle. So the compensated bundle, again, is essentially, given the decrease in the price of good one, how much would I have to take from you in order to make you, in a sense, just as happy as you were originally? And so in order to show this, we compute the sort of full effect. And so I went from 25 units of X to 50 units of X. And so from the substitution effect, I can see that 10 of those units, 10 of the units increase came from substituting, that is increasing my consumption of X, and in a sense decreasing, comparatively my consumption of Y. And then the income effect is going to be close to 15. So the remaining 14 to 15 unit increase in X comes about because of the income effect. Now, the way that I'm able to know this is because I make use of this dotted line here. This dotted line is that compensated demand. You'll notice that this dotted line is just a shift of this new budget constraint, the after the decrease in the price of good one budget constraint. So again, the question is, how much money, M, could I take away from you such that you were just as happy as you were before? And if I did that, the idea here would be that this individual would consume bundle C. So at the new prices, with the price of good one being lower, and if I took money away from you to keep you just as happy, that is on the original indifference curve, then this individual would consume bundle C. You'll notice that bundle C compared to bundle B is less X, right? And considerably more Y. I'm sorry, less X and considerably less Y as well. But the difference between C and B, right, as we can see here, the difference between C and B ends up being that income effect, right? So the movement from A to C in terms of good one represents the substitution effect, and then the movement from C to B in terms of the consumption of good one represents the income effect. And again, preferences are going to dictate this particular mechanism. So to the extent that you actually see changes in the mixture of substitution income effects, they are governed ultimately by those preferences. And like I said, if you go through, you'll see that I have some examples to sort of walk you through those substitution income effects. The sort of broader point here is that when the price of a good or service increases, the consumer is going to respond by changing their mix of the two goods that they're consuming. So the bundle that they're going to consume is going to change because, again, we assume that consumers are optimizing. If the conditions under which they are optimizing changes, then how they optimize and what is considered optimal is also going to change. Okay, so we now have established utility, budgets, utility maximization, and also a brief discussion on income and substitution effects. So this allows us now to get into really bringing this conversation into sort of the macro world. So the way we want to think about this model that I'm going to talk to you about, it's going to be a model that we refer to as a dynamic savings model. So in this model, we're going to start from the perspective of there being multiple time periods. So there's going to be a time period T, and there's going to be a time period T plus one. That time period T plus one, we can essentially think about as the future. Now, the idea here is that individuals in your economy are what we refer to as representative agents. So in other words, we can't capture everybody's unique indifference curve. I'm sorry, everybody's unique utility function in order for us to put together a macro model. So what we instead do is we rely upon the idea that a singular utility function sort of represents a representative individual in my economic system, and then I'm going to sort of make an assumption that sort of says people are generally going to behave in this manner. But of course, knowing in the back of my mind that utility functions tend to be very, very distinct. As I mentioned to you before, the reason why we're talking about this is because consumption is such an important part of a modern economic system. And then the only sort of thing that we want to kind of just sort of positionally think about is that we're going to think in terms of units of things here, ultimately. So when we talk about consumption, we're going to be thinking about consumption in terms of the amount of goods that I'm ultimately going to consume. And the reason ultimately that I'm going to think this way is because we are going to essentially take away the idea of prices. We're going to normalize the idea of prices. And then what we're going to sort of be able to show is that the opportunity cost of consuming in the current time period versus consuming in the future time period is going to be related ultimately to the interest rate. So we'll talk about that in just a moment. Okay, so here are the basics. So the idea is that the representative agent is going to have two income realizations. They're going to have an income realization in time period T, and then another income realization in time period T plus 1. They're going to consume CT and then consume CT plus 1 in the future time period. We're going to assume no savings, so there's no endowment here necessarily. Everybody starts with 0, and so the only income that you get is YT and then YT plus 1 in the future. We're going to make a couple of other just sort of simple economic assumptions. We're going to assume that the household earns or pays a real interest rate RT. So if they borrow money, they're going to pay the interest rate. If they lend money, they're going to earn that interest. We're going to assume that the household has no influence on the interest rate. So there's no market power in this particular model. And so the representative household is a price taker, an interest rate taker, if you will. And there's not going to be any sort of bank or anything in this particular model. We're only going to think about this from the perspective of the consumer. Now, in the intertemporal setting, we have essentially two different budget constraints. Okay, we have the budget constraint in the initial time period, and then the budget constraint in the future time period. So the idea is that whatever I don't consume of my income in the initial time period, I will then have that money plus some interest for me to consume in the future time period. Right? Think about 401k. 401k is foregone current consumption so that I may consume more later in life. Okay, this is going to be related to this concept that we're going to call consumption smoothing. We typically think that people like to smooth their consumption over their lifetime. People tend to try to avoid big spikes in their consumption over their lifetime. And that actually ends up being a fairly important kind of dynamic in terms of how we think about, again, people's reactions to things like interest rate changes and so on and so forth. So here we start to have conversations a little bit about sort of stock versus flows. And so the way that we're going to think about income here is that income is a flow. In other words, I get a money flow in time period T, and then I get another money flow in time period T plus 1. And then if I save some of my money in time period T, then that, in a sense, ST is going to represent savings that I could use in the future time period for consumption. And then we typically make assumptions like that you don't save any money in the second time period because because no one saves money. They spend all of their money before they die. So that's going to be one of those assumptions that we tend to make as well. Okay, so here's just some basic ideas here. Again, some assumptions here that we sort of mentioned before. All right, and then let's move on. Okay, so now let's set up what we refer to as the intertemporal budget constraint. So the intertemporal budget constraint is going to be a budget constraint that I face over both periods of my life, the current time period as well as the future time period. Now, the idea of the budget constraint here is exactly the same idea as it was before. My budget constraint is that I cannot consume more than my income. So my consumption in time period T and my consumption in time period T plus 1 cannot exceed my income in time period T and my income in time period plus my income in time period T plus 1. Now, it's important to point out that when we talk about consumption in the future time period, when we talk about income in the future time period, we want to discount that back to the present. So you'll notice here that we say, let's look at the right side of this intertemporal budget constraint. We say that the consumption in time period T plus the discounted value of consumption in time period T plus 1 is going to be equal to the income in time period T plus the discounted value of the income I receive in time period T plus 1. Right? Because of the intertemporal nature of my income flows, I'm going to discount future flows of money. So that future income flow is going to be discounted back to the present. And the way that I discount it back to the present is I divide it by 1 plus the real interest rate. Okay. And then in terms of consumption, that's going to then mean in the future time period, I'm at most able to, in terms of net present value, I'm able to consume CT plus 1 over 1 plus RT. Again, this is what's called the intertemporal budget constraint. It's sort of the lifetime budget constraint, if you will. And what this ultimately says is that the present discounted value of the stream of consumption equals the present discounted value of stream of income. So basically, the flow of consumption is going to be equal to the flows of income. Now, let's take you through the math and graphically illustrate that intertemporal budget constraint. Okay, so let's imagine for a moment that I am going to get in time period T, and by the way, let's just do this. We'll do T is equal to 1 or 2. And so instead of T and T plus 1, especially when you're on the whiteboard, it's hard to kind of keep track of everything. So we'll say Y1, I'm going to get $100. And then in Y2, I'm going to get $110. Okay. And then we will also assume that the real interest rate is 10%. Okay. Now, my intertemporal budget constraint is going to look like this. CT, and let's just go ahead and do C1 plus C2 over 1 plus R is equal to Y1 plus Y2 over 1 plus R. Now, we want to graph this, and so the way that we're going to graph this is a little bit complicated. So we have C1 here and C2 here. So C1 on the vertical, I'm sorry, C1 on the horizontal axis and C2. So that's consumption in the current time period, and then consumption in the future is on the vertical. And so we know that the intertemporal budget constraint is just going to be a linear function, okay? And just like the budget constraints before, we ask ourselves, okay, if I want to know what's the most I could consume consumption in the current time period, and that would be if I spent all of my current money plus future money on consumption in the current time period. And so we ask ourselves, what is this sort of particular value here? Now, this is where I was mentioning to you before. We can essentially think about the price of consumption as being one here. Right. You'll notice we haven't really mentioned the price of consumption, because the idea is that a dollar of income is going to equal a dollar of consumption, is essentially the way we're thinking about it. So the prices of C1 and C2 here are essentially one. And so if we ask ourselves, what's the most amount of C1 that I would have access to, it's going to be the amount of C1 that I could purchase with my current income plus the discounted value of future income. And so that's going to be y1 plus y2 divided by 1 plus r. Then the amount of money that I could spend on C2 is going to be the future value of my current income. So income in time period 1 in the future plus the income I'm going to get in the future. So 1 plus r times y1. That's the future value of my flow of income in time period 1, and then the amount of money I get in time period 2. And so this is how you generate your intertemporal budget constraint. Okay, the most amount you can spend on C1 is just going to be the amount of money I get in time period 1 plus the discounted value of the money I'm going to get in the future. And then the most I could consume of C2 would be the the future value of the money I'm going to receive in time period 1 plus the income I'm going to receive in time period 2. And so we can relatively easily go through and do these particular calculations because we have all the values for it. So we know that y1 plus y2, that's equal to 100 plus 110 divided by 1.10. And so that's just going to be 100 plus 100, and that gives us 200. So this intertemporal budget constraint starts right here at 200 units of C1. So the most amount I could consume of consumption in time period 1 will be 200 units. And then if I want to do this value over here, I just have to do 1 plus r times y1 plus y2. So that's 1.10 times 100 plus 110. And so then we get 110 plus 110 is equal to 220. So that is how you construct a intertemporal budget constraint, right? Just like budget constraints before, except the thing is now you have to think about I'm spending money over my lifetime. Okay. Now, what's going to sort of matter eventually, of course, is that you are going to have, in the context of C1 and C2, you're going to have your intertemporal budget constraint, and then you're going to have your indifference curve. So the idea is going to be, based upon your preferences, there's going to be an optimal consumption in period 1. There's going to be an optimal consumption of in time period 2. And so the idea again here is that we have an optimal bundle. Now, the question is, what can change the optimal bundle? So assuming that preferences don't change, what ultimately is going to change the optimal bundle? So the question here ends up being, what is the slope of the budget constraint? I should say, intertemporal budget constraint. Because remember, the prices of everything is one here. So what's the slope of the intertemporal budget constraint? Well, the slope of the intertemporal budget constraint is going to be 1 plus R. So that means that the slope of the budget constraint will change when interest rate changes. So now if we're talking about interest rate policy, right, the central bank increasing or decreasing the interest rate, we now have an idea of what that potentially is going to look like in terms of the intertemporal budget constraint. So let's draw another one here. C1, C2. Okay, so y1 plus y2 over 1 plus r, and then 1 plus r times y1 plus y2. So what happens if the interest rate goes up, right? If the interest rate goes up, what I should notice is that this value is going to decline and this value is going to go up, right? Because my discounted value of future consumption is going to go down. It has no impact on y1. Y1 doesn't change, but y2 divided by 1 plus r is now smaller when the interest rate increases. Additionally, we can see y2 doesn't change because r changes. However, 1 plus r changes. And so the future value of current income, 1 plus r times y1, is going to increase. So what that means is that when the interest rate changes, your intertemporal budget constraint also changes and oops. Let me draw. It's hard to draw like nice straight lines on the tablet. Boom. So we can see that the intertemporal budget constraint sort of pivoted in two different directions. So it now hits a higher point on the vertical axis and hits a lower point on the horizontal axis. So basically what that means is that when interest rates rise, it becomes more expensive to consume in the current time period, and it becomes cheaper to consume in the future time period. And so when interest rates rise, we tend to expect people to forego spell. So the idea here is that if interest rates rise, kind of all else equal, and sort of assuming that consumers have well-behaved preferences, as we typically assume, then we tend to expect people to forego current consumption in order to consume more in the future time period. Because if interest rates rise, savings is more powerful than it was otherwise. And so spending less money in the current time period makes economic sense, and then shifting that consumption to the future time period. Now, of course, if interest rates were to fall, you would get the exact opposite effect. But it's just important. And again, let me, sort of the idea here is that we start, with this initial budget constraint here under sort of the initial market conditions. And then for some reason, either the market or because of policy, interest rates rose. And when interest rates rose, we now have this new intertemporal budget constraint. Now, this is still a linear line, but I'm just drawing it here. Oops. There we go. So pivot in here. All right. Okay, so my apologies. I thought I dropped it there, but I see that we didn't. So we can go here. So The argument here basically is that the way that we think about the intertemporal budget constraint is that the interest rate has an outsized effect ultimately on how people shift their consumption either from the current time period into the future time period. And in particular, our expectation is that if the interest rate goes up, people will shift their consumption from the current time period to the future time period. Now, the extent to which this occurs, of course, ends up being about the substitution and income effects that we were talking about before, right? For some people's preferences, this increase in interest rate will lead to particular changes in their consumption over their lifetime. And for other people with other preferences, the change in interest rate might lead to, a different sort of set of behaviors. But again, sort of generally speaking, and with those well-behaved preferences, we believe that an increase in the interest rate today causes a shifting of consumption from the current time period to the future time period. And again, that is related back to this idea of consumption smoothing.